Okay, so question 8 says a student states if x and y are irrational numbers and x is not equals to y, then xy is also irrational. Show by counter example that this statement is not always true. Okay, what does it mean to be a counter example? Counter example means you are going to give their reverse example. Like when they are saying you that they are irrational numbers, and so the x and y should also be irrational, so you are going to give an example that are irrational number but their product are going to be rational. Okay, so you are going to be giving them an example which is going to prove it to be wrong. Okay, so a counter example. So let's get into details. X and y are irrational. What does irrational means? Like some common example of irrational numbers are all the numbers that are not complete square under the root, or most common examples include the numbers that have pi in them. Okay, involving pi in any way is your irrational number. X is not equals to y means they should not be same. Then xy, their product should also be irrational. So let's look into this. We need to prove that if you take two irrational numbers, let's suppose 2 root 8 will give you equals to root 16, that is equals to 4. Okay, this is giving you a product, and 4 is a rational number. Okay, because what are rational numbers? Rational number means that can be written in p over q form. Okay, so all the natural numbers, all the whole numbers, all the numbers are obviously rational numbers. So this is proved. Like if you take two examples like this, or you can take another example. I can show you another example like this, which two numbers when multiplied give you a complete square, but when itself they are under the root, they are irrational. Like they are not the complete square, so they are irrational. So 12 root 3 gives you 36, and 36 is a complete square of 6, so 6 square and square root will be cancelled, so it gives you to be a rational. Okay, so in this way you can give some examples, and by counter example you can show that since as x and y were irrational but they are giving you xy is rational, so this statement is not always true. Secondly, prove using algebra that for all odd integers the value of the expression is always even but never a multiple of 4. So how do you write an even number? You write an even number to be like 2 times. Okay, we can take any variable for it, not taking n, or we can take x. 2 times x is your even numbers, like where x is like the natural numbers, the real numbers. Okay, it gives you even. But if you do 2x plus 1, this represents all odd numbers. So they say that if for all odd integers the value of the expression, okay, so let's put this into your equation, n cube plus 3n plus 2. Substitute in 2x plus 1, so it will become 2x plus 1 whole cube plus 3 times 2x plus 1 plus 2. Okay, so it will give you, okay, thinking it to be making it a little easier, you can have, it should be always even but never a multiple of 4. That means it should not be a multiple of 4. It should be something, it should be even, but not a multiple 4. So 4 times there should be an expression plus 2. So it must be even, but it should never be 4 times. Okay, so just solving it up to make it a little simple. I'm taking 2x plus 1 common, so we will be left with 2x plus 1 square plus 3 plus 2 plus 2 is outside. Next, further we will be okay. Why I have done this? Not to solve, like if you don't want to solve the cube by applying the formula. Yes, we do have a formula for a plus b whole cube, so you can apply that as well. But if you, in case you don't want to, then do it like this. So 2x whole square will mean 4x square plus 1 plus 4x plus 3 plus 2 and whole times 2x plus 1, like this. 2 is outside. Now what do we get? 4x square plus 1 plus, sorry, plus 4 plus 4x, 3 plus 1 is 4. So this is going to be, if we take 4 common out of it, we will be left with 2x plus 1 times x square okay, 4 times some expression plus 2, or you can solve it also further, that can make it more reasonable. Okay, it's also fine, it is also acceptable. Okay, this is going to give you the same, or if you want to multiply it further the x expressions, it's all totally fine. Okay, you may solve it further and solve it out. So this expression is giving you that you are getting 4 times some expression plus 2. So this is always going to give you, this expression is always going to give you an even number but not a multiple of 4. I hope you understand this. That's all. Your part 1 and part 2 for question number 8.